In this case, we are going to consider as a continuation working with our matrices, and that is the multiplication of matrices. So you'll find out that when you are dealing with matrices, mostly it is about the order of the given matrices, all right? We saw that on addition and subtraction. So on the multiplication, again, it is about the order, but not to say that a 2 by 2 is to multiply a 2 by 2. Yes, it can happen. A 2 by 3 is to multiply a 2 by 3. It is not only a condition of the same order, but multiplication lies on the order of the given matrices in this manner. If the first matrix that you're given, let's say it is an order of 2 by 3, okay? And the second matrix that you are to multiply is starting with this number, which is 3, the last one, 2 by 3, then it is starting by that. It can be a 3 by 1, a 3 by 2, a 3 by 4, whatever that you are given there. As long you are having these two being the same, all right? For the first matrix, the column 2 by 3, the 3 for the column. For the second matrix, the first one representing what? Representing the row. Remember, rows by what? Rows by what? Row by column concept. So if the column of the first matrix is the same as what we have there, the number of the row for the second matrix, if they are the same, multiplication is possible. So if a P by Q matrix and a Q by R matrix are being multiplied together, these two, Q and Q, are supposed to be the same. It shows us that multiplication is possible. This is the possibility of multiplying. So multiplication is possible. This just tells us that multiplication is possible. So what remains, the 2 and the 1, will give us the order of the final answer, which is the final matrix. Our final answer is going to be a 2 by what? A 2 by 1 matrix. That is your final what? Your final answer. If you are to consider here, P by R is going to be our final answer, 2 by 1, 2 by R matrix. It will be the final answer. So that is the condition for a multiplication. All right. So how do we multiply? Because here we just saw, all right, it is possible for us to multiply because these two, they're the same. Then the first and the last there will represent the order of the matrix of what? Our final answer. So how do we multiply now? So to multiply, you consider row by columns. So you multiply rows by what? By columns. So I'm going to show you how do you do or apply that or put that into consideration to multiply rows by what? By columns. So let's say we have a 2 by 2, all right, matrix, and maybe a 2 by 1. Okay, so let us say we've got something like 3, 4, 5, 7. Okay, this is our first matrix, which is a 2 by 2. And the second one is a 2 by 1, like this, all right? That is 2 rows and 1 column. So this is what we have: 2 rows, 2 columns. The first matrix, that's a what? 2 by 2. The second one, 2 rows, 1 column. That's a 2 by 1. So we can see that multiplication is possible by combining these two. They are the same: 2 and 2, 3 and 3. Q and Q, they're the same. So what remains is the order. The 2 by what? The 2 by 1 will be the order of our final answer. So we must obtain the 2 by 1 matrix. All right, so this is how you simply multiply. As I said here, it's rows, multiply rows by what? Column. So you take this, the first row is this one, 3, 4, to the column, to this column that you're having here. So it is this row corresponding to what? To this column. Okay, so this is how we're going to multiply. So we take 3 multiplying to 2 on that row, this row to this column. So that is 3 multiplies what? 3 multiplies 2. But as we can see, in this row that we are having, in this row, we still have another element 4 in that row. That 4 is supposed to multiply the 3. All right? So we are supposed to have the 4 multiplying the 3. So we have row by column. So 3 multiplies 2, 4 multiplies what? Multiplies 3. But as we are to consider that, because it is the same row that we have taken the 3, that is the same row where the 4 is, you add. So you must add that part. All right. So you're going to add the part of what? 4 multiplying what? 4 multiplying 3. So this is it. All right. Then we consider. All right. So in this case, we are done with the row and the column, the first row and that column. So we move on to the second row. But as you can see, we only have what? A single column that. So that second row is going to multiply this single column as before. So meaning to say 5 is going to multiply 2 as we saw 3 and 2. So 5 is multiplying what? 2. So that is the concept. So it's going to be 5 times what? 5 times 2. Okay, so this is it. Since we have another element 7 on that same row, we are supposed to add that. So 7 multiplying what? 7 multiplying 3. So you have to add that 7 multiplying 3. So this is what you're going to have as your resultant. So this is, you multiply whatever that you get, you add to that. So here, if you're going to multiply, that was going to 3 times 2, which is 6 plus 4 times 3, which is what? 12. Then you add 6 plus 12, which is what? Which is 18. So this is what you're going to have here. All right, so that was going to give us 18. You do the same thing, 5 times 2, that is going to give us a 10 plus 7 times 3, which is what? 21. So that was going to give us what? 21 at the end, which is according to the order 1, 2, 1 column. So you've got 2 rows. All right, we've got what? 2 rows. And how many columns? 1 column, which is a 2 by 1 as we had here. That our answer is supposed to be what? A 2 by 1 matrix at the end. So it is very, very important to consider that on your multiplication. All right, so it can be a 2 by 2 multiplied to a 2 by 2. Yes, it is possible. Same order. All right, let's say we're given matrix A, which is negative 1, 2, 3, 4, and matrix B, which is given as 0, 5, negative 1, 3. This is what we are given, and you're being asked to find or to determine the product AB. So AB is simply representing matrix A, all right, minus 1, 3, 2, 4 times matrix B. So you multiply to the matrix B 0, 5, minus 1, 3, which is same order in this case, all right? So do not worry about that. 2 by 2 and what? A 2 by 2. Is it possible for us to multiply? Are these two the same? The last and the first of our order. Yes, they are the same, 2 and 2. So multiplication is possible, and your answer is going to be what? A 2 by 2. That's our final answer, a 2 by 2 matrix. So as we are multiplying row by column, so let's perform on this one and see how it was going to look like. So we have got the row, this row, the first row, but the second matrix has got what? 2 columns. Take note this row, but here there are 2 columns. So it is going to affect the first column, this one. All right. First, let us consider for the first column. It is the same thing as we had before, -1, 3, 2, 4, like this. We'll remember the one that was having a 2 by 1. It was -3 multiplying this column. So this is what is happening. -1 and 3 multiplying the column. So this is the same, -1, 3 multiplying that column first. So -1 is going to multiply what? 0. -1 times 0. Okay? Whatever that we are going to have here, we are supposed to add because we still have 3 in that row. Just like what we had, 3 multiplying what? 3 multiplying -1. Remember the concept that we had before. But because there is another column in for that second matrix, so it is like we're done with this column, then there's another column. So the same row is going to affect the second column. So this is for this column. So here for the first row and first column, you write it for the first column. So you leave a space for the what? Second column, because these elements are on the second what? Column. But multiplying from what? From the first row. We are still having a column here that has to be considered from what? From the first row. So -1 versus 5. All right. So that's -1 times 5 and 3 versus what? 3. So you have to add that part. All right. So you have to add because we are still from the same row. So 3 multiplies the what? 3 multiplies the 3 here. That is the concept. So this is the concept of multiplication, row by column. So this row to the first column, this is what we had to this column. This row to the last column, you write it corresponding to that column, all right? So it is because the second matrix has got what? 2 columns. So the first row has to affect both columns. All right. So this is the same case that we are going to have if we are to consider the second row. So for this second row, it is going to affect the first column first, just like what we had this row in the column. So that is 2 multiplying what? The 0 there. So we're going to have 2 times 0, all right, plus 4 and what? 4 and -1. 4 times what? -1. We are done. The row and the column. But there's another column here. There's another column. So that same row has to affect that column. You have to write it corresponding to that column now. So this is it. 2 multiplying what? The 5 there. So that's 2 times 5. Then we add 4 versus what? 4 versus 3. 4 times 3, just like that. So this is the concept of multiplication. So with this, you can combine this, all right? -1 times 0, that's what? -1. Guys, any number times 0, that's a 0, isn't it? So here, that's a 0 here, plus 3 times -1, that's what? -3. -1 and 5. So, all right, no problem. The next one, I'm just gonna leave this stage of writing a lot of things there, all right? 2 times 0, that's a 0. We add to 4 times -1, which is what? -4. 2 by 5, that's 10. 4 by 3, that's what? That's 12, okay? So this is what you're going to have. And the final answer, you simply have to add 0 plus -3. That's 0 minus 3, which is what? -3. Minus, all right, here's 0 minus 4, that is -4. -5 plus 9, that's simply 9 minus what? 9 minus 5, which is 4. 10 plus 12, that's going to be what? 22. So this is what you're going to have at the end. So like I said here, guys, I'm just gonna avoid like writing it. This you can even just do it in your head, like minus 1 times 0. All right, let me just quickly do something like that. Let's say you're being asked from the same part to find a squared. A squared. The square of A simply means matrix A times matrix A, minus 1, 2, 3, 4 times that same matrix. Be very careful not to square these numbers, but to multiply it, to multiply the same matrix. So this stage, I'm just going to avoid like writing this. You saw that it is the row to the column. So let's do it in our head. Minus 1 times what? Minus 1. That's positive 1. We add because we still have the 3 in that row. 3 times what? 2, which is 6. All right, so we're done with the first row, first column. Move on to the second column. Let us do it in our head again. Minus 1 versus what? 3. Minus 1 times 3, that's minus 3. Then we add, because we still have another element in that row, 3 and 4. 3 times 4, that's what? That's 12. All right, so we can remove some of unnecessary multiplications. I'm not saying it is unnecessary, but we can avoid that by just doing it in our head. All right, so let's consider the second row, considering to the first column. The same way like before, 2 multiplies what? Negative 1. 2 times minus 1, that's minus 2, plus 4 times what? 4 times 2, which is 8. We are done with this one. We move on to the second what? Column. 2 versus what? 2 versus 3. 2 times 3, that is 6. 4 and what? 4. 4 times 4, that is going to give us what? 16. That is 4 times 4. 4 squared. All right? So that is what? 16. So from there, you simply have to add. As we can see, we've reduced our calculations by simply doing this in our head. So 1 plus 6, that's a 7, minus 3 plus what? Plus 12, that is going to give us a positive 9. 12 minus 3. Minus 2 plus 8, that's simply 8 minus 2, which is 6. 6 plus what? 6 plus 16 is going to give us 22. So that is it. This will be our final answer. So A squared simply means matrix A times matrix A. Do not mistaken this to take that matrix that you are given, you square it like this, then you start to square the numbers, each number. Do not consider that way. It simply means that matrix times that matrix, right? So that is basically what you're going to need for the matrix multiplication. So I want you guys to do as many questions as you can, all right? Where you do not understand, let us communicate. That's why we've got the comment section, the community section, so that we can do our revisions where we do not understand. And if there is any part that is not yet done, let us also communicate so that we can have that done as soon as possible.